Alright everyone, welcome back to another video. This is going to be hopefully a short one. In this one we're going to be doing a solid geometry drawing. For this question or this problem, this figure 2 here shows a drawing in isometric projection. As you should recall, isometric projections is a type of three-dimensional drawing. The key thing about it being that the angle of these receding lines are at 30 degrees. This line here, all these receding lines, all these diagonal lines are at 30 degrees, and all of these vertical lines are 90 degrees. Okay. In isometric drawing, circles are represented as ellipses, so they look like ovals. Ellipses is what we call them. And but if you look at it straightforward, it will be a normal circle. Okay, so in this drawing, what we're going to be doing, it says the problem says to draw the orthographic projections of the isometric object below with the front elevation in the direction of the arrow. So and it says to use the third angle projection. So we are going to be redrawing this in orthographic projection, specifically the third angle projection. With the arrow, the front elevation is what the arrow is pointing to. So we are basically going to draw this in third angle projection. This is our front. Where the arrow is pointing to is going to be our front. Alright, and as you should recall in third angle projection, in orthographic projection, it's a way of drawing three-dimensional objects in two-dimensional by using two-dimensional views. So this is a three-dimensional object. You can see it has a front, it has the front here, you can see the top here, you can see the side here. But we can draw this same object in three different drawings. One drawing showing the front, one drawing showing the right side, and one drawing is showing the top of it, or the plan view. Now, we're going to be using the third angle projection, and if you recall, with third angle projections, let me just pull something up. You should recall, or let me just explain it if you don't know. The concept is this of third angle projection. Imagine you have this object and there is this separation. These are four quadrants, right? We have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. When we do first angle projections, the object is placed in the first quadrant. Let me see if I could skim through to it. Right, so we see the first quadrant, the second quadrant, when it's first angle projection, let me just explain this quickly. The object is placed in the first quadrant, and then we imagine that you are looking at the object. So if you're standing here and you look at the object, then you would be basically projecting this onto this surface here. And when you do that, it is going to leave this view on top of the object here. So we could see that happening here. Then if you come from the top and look down, then you will project that top view onto the bottom. And then if you come to this side where the arrow is and look to the object, look at this side view, it will project it onto the auxiliary views over here, like so. And if you come to the other side, if you go to the other side, look at the object from this direction, then it will be projected onto this side right here. And basically once that happens, we unfold the quadrant, all the sides of the quadrant, and then we would see the object ends up like in this position. So we see the top, well, we see the front is placed at the top, the bottom is the top view is placed at the bottom, the left side well, the left side is placed on the right and the right side is placed on the left. Okay, because remember, this is the left side, it is placed on the right. And this side over here, if you're looking from this direction, is going to be projected onto this auxiliary view, this auxiliary plane. All right. So I like to think of it as saying in first angle projection, all of the views are reversed. So the front is here, and then you have the top view placed at the bottom, and the left view is placed on the right, and the right view is placed on the left. But for third angle projection, the object is placed in the third quadrant, first quadrant, second quadrant, third quadrant. And basically, we cannot see through the quadrant, so we'll have to make it transparent. Now, because of this, the the these panels are in between the viewer and the object. So instead of projecting it onto it, we basically can see it through the object. So this, if this is your front is going to be right here. Okay, and then let me see if I could just skip through this real quick. Right, so if this is this is your front here, it is placed onto this plane right here, and then we can see the top of the object on this plane right here. And then obviously when we want to see this side, we could put, let's say we put a glass right there, we will see it show up on this side, and the same thing for the other side. We put the glass right here, and then we will project it onto the glass like so. Same thing on this side. And then when we unfold the object, let me see if I could let the animation play out here for a second. We unfold it, bam. So we have the front view now is at the bottom, the top view is at the top, the left view is at the left, and the right view is at the right. So in third angle projection, all of the views, I like to say that they are where they're supposed to be. They are in the correct position. The top goes at the top, the left goes to the left, the right goes to the right, and the front view is always right there in the middle of the two side views. So for this drawing that we're going to do, we are going to turn this drawing into a third angle projection drawing, a third angle orthographic drawing, whereby the arrow is pointing to the front. So one more thing, if the arrow is pointing to the front, and this is your front right here, looking from this direction, then the front, we're going to see all these things that are colored in green, we are going to see them like so. So you're going to see this little L-shaped looking thing here. Well, not an actual L, but you know, it's we'll see inside here. We're not going to see this face if we're looking from this direction. We can't see this, we can't see on the sides here, but we can see this surface. We will also see this surface, and we will also see this surface here. When we look at the object from the top, we will see the red, all of the red. Okay, and then from the top, this part is not going to look curved. You cannot tell that it is curved. From the top, it is just going to look like a rectangle. Okay, so we'll see this shape, and we'll see a rectangle right next to it. And then finally, from the right side, we are going to see a rectangle like this. But as you know, in technical drawing, we also have to represent things that we cannot see with the naked eye, okay, by using hidden lines. So we would be able to depict this cutout. It goes in, let's say, 10 millimeters. You would see a dash, a hidden line come down here and come across to represent the cutout. Also, when looking at the object from the top, we will see lines representing the two ends of this circle that is cut out from here and here if we're looking from the top. Okay, and because it's a circle, we will also have to show a center line in the middle of it to show where the center of the circle is. Alright, so without further ado, let's get right into the drawing. This is AutoCAD, so we're going to do things a little bit faster in terms of we don't have to necessarily do all of the stuff that you would do with traditional drawing. In terms of drawing it with construction lines and then darken it up after, we can get straight into the drawing. Alright, so let me just open this so we could go back and forth between this using the measurements that we have here. Alright, so let's start with the front as always. So let me hit straight to the object layer. We can draw the front. So let's remember where the arrow is pointing is the front. So let's draw the front. We're going to see everything here. This line come across. We're going to see it go up. We're going to see it come back across. We're going to see it come down, go in, and so on. Remember, we are not drawing it at an angle. The isometric drawing is at 30-degree angle, but the orthographic projection is going to be as if we're looking at the drawing straight ahead. Therefore, we can draw this line straight across 10 millimeters, like so, and then this line comes up 20 millimeters, like so, and then we come across all the way across to here. 10 plus 15, that's 25 millimeters. Then we come down right here. 10 is here, so that means there's 10 remaining because the entire thing is 20. So we come down 10 millimeters. Then we go back in 15 millimeters and we come down 10. Then there is this portion right here at the back. We go in, but we can't drop, we can't see how much we go in from here. All we know is that we come across 10 millimeters right here. So from here, 10 millimeters, come down, 10 millimeters, come back across, 10 millimeters. And then finally, let's do this piece, come across here. If 10, 20, 35, we have 35 from this point all the way up to this point, 35 millimeters, and the entire thing is 70, then you've guessed it. All we have to do is take away 35 from 70 and we get this distance, which is 35 also. So from here, come across, it's going to be 35. We come down 20, which is the same as over here. 20, we come in 10, like so. Then we come up, same 10, like over here. And then we come back across all the way right there, like so. So there we have it. This is the bottom part here of the front view. All of the parts that are in green. But we have this piece at the top here. Now there's some information about the top that we have to take into consideration. We can see that this is a circle, well, half of the circle at least, and we can see that the radius of this circle is 10 millimeters. We can also see that there's a bigger circle outside of that, and if we just forget about this piece for now and just think of it as a circle coming down right here, then the radius of this circle is 20 millimeters. So we basically have two circles, one with 20 millimeters, one with 10 millimeters, and then we will just join this corner to the tangent of the bigger circle. So I'll do this with my arc tool. First thing I need to do is find the center of the circle. Okay, so where is the center going to be of the circle? How far from this edge is the center of the circle? And the way I would figure that out is by knowing, first of all, that both circles, the smaller one and the bigger one, they share the same center. So the center is somewhere here, right? But I don't know the distance. But actually, we do know the distance, because if the radius, remember the radius is the distance from the center of the circle to the circumference. from the center to the end of the circle or the circumference. And the distance, we know that the radius is 20. So if we go 20 from the edge inside, that is going to give us the center of both circles. So I'm going to use my arc tool, center start end, and I'm going to just mark an arc 20 millimeters right here. And this mark is going to be the center of my circle. So go to the circle tool, center radius, click the center, and I'm going to draw the first circle. 10 millimeters is the radius, and then I'm going to draw the second circle. 20 millimeters is the radius, and notice it gets right out to the edge, as we said. So we can delete this line, and then we can trim away all these lines below, because as we could see in the drawing, the circle does not go all the way through. It stops right on top of the object. Alright, so imagine this is a rectangle, and then the circle is the half of a circle. This piece is placed on top of it. Alright, so there we have that. And then all we need to do now is draw a line from this corner to the tangent of this circle. Now, instead of trying to find the tangent and all of that, because the tangent you have to draw a line, the normal, which is from the center past the circumference, and then we find something perpendicular to it and all that. We're not going to do that. We can just turn on our tangent snap. If it's not on, turn it on. Tangent snap. I'm going to turn off all these other snaps so that they don't mess with what I'm trying to do. I'll leave on the endpoint. So as you can see, the only snap that is showing up is my tangent snap right here. Okay, so this line, that's the point of tangent, and it runs all the way to the end. So we just need to trim this part out. So there we have the front of the object. Alright, now we still need to finish up a few things. We would need to put in dimensions and so on, but let's draw the objects first, and then we'll come back and do all that after. Alright, so we're going to leave some space in the object, between the object. So we have the front view. Now we need the top view. Now imagine you're looking at the object from the top. You're going to see everything in the red. So you'll see this rectangle with a cutout here, and we'll see another rectangle, this red part, right alongside it, whatever the measurements are. You're not going to be able to tell it's a curve. It's just going to look like a rectangle from above. Alright, so let's get the measurements. The top view, well, as you should know, in orthographic projection, we don't necessarily have to put in all the measurements when we're drawing it. We could just do projection lines from all of the corners, all of the edges of the object, and these lines will tell us exactly where to stop when we're drawing our next view. So before we do anything, I just want to put a little space in between the object. So the space between the object, just so that I'm going to give it to you because I want you to be able to fit it on a piece of paper. So I'll actually give you the space. So let's draw a line, a construction line. Let me turn back on the nearest perpendicular. I don't need the tangent anymore. I'm going to draw a line from the top here. Let's come across like that. Now this line is just going to be so that I could create a space in between the objects. I want to have a line. I want to have some space above the object. Let's leave us a space of about 25 millimeters above this object, and then I offset another 25 millimeters. This is going to be where I'm drawing my next object. Okay, so this is the line in the middle to separate them, and this object is 25 millimeters, about 25 millimeters from this one, and then the next object above here is going to be 25 millimeters from the middle line. All right, so let's project some lines from all of the corners, the edges of the object, like so, and then I'm going to just copy this line and place it at all of the edges. So one right here, one right here, one right here, one right here, and one right here. Now I need to put some lines right here also. There's one here already because they are lined up. Here and here is lined up, but I need to put one here also, but I'm not going to put it just yet because I don't want to get confused when doing my drawing up here. So remember, in doing orthographic projection, you should already kind of know what the object is going to look like. So we're going to see, looking from the top, we're going to see this line, then we're going to see it goes in, it's going to come across, come down, then we're going to go across again, it's going to go back and come across, and then we're going to draw the other part. So let's get the measurements. It comes across 25. We don't need to actually measure that because we could see if this front was drawn correct, then we know that we could just then we know that we could just draw this thing right here. Let me just put on the intersection because there's an intersection happening. So from here, we know that we could just come across to this line right there, and then we go up. Let me turn on perpendicular and get rid of the nearest for now. I come up 10, and then I come across 10. I don't need to measure it because down here is correct already, and I come back down to the line, and then I come across all the way across to the end right here. Now I go up. How much do I go up? The whole thing is 35. So if I minus 15, I get 20 right here. From here to here is 20. So I come up 20, and then I go across the back like so, and close it off like that. So that's the front, that's the first part, this part down here. Now I need to do this part, which is 15, and then we just come straight across the back. Alright, so we come up 15, and then we come straight across the back and come down like so. So this is, you can't tell that it's a curve because we're looking from the top view. Alright, so now we have this cutout to think about. So now I could use one of these lines. I'll copy this line and place it right here. So there's one here and there's one here. Looking from the top, we can't see this cutout, this circular cutout directly, but looking from the top, we could represent it with hidden lines running down where these two lines are, right here and right here. So let me just switch to my hidden layer and draw my line right there and right here, like so. And now I just need to change the line type scale to something a little bit bigger. Let me see how 10 looks. Alright, that looks good. If I turn off my construction layer, you could see it right. So that's what I want to see. So these lines represents the two corners, the two ends of the circle or the semicircle that touches the object. And because it's a circle, we need to show that the center of that circle. Alright, so we need to add a center line. So if you don't have one, you need to create a center line. In your layers, create the center line, make it a color, choose the line type center, or if it's not here, load it in. It's in alphabetical order, so you'll find it center, any one of these, and then click this and load, and okay. So that will make the line a center line. You can change the line weight because a center line is not very thick, and I just need to switch to this layer, right? So we will draw a center line running all the way between here, coming all the way down here. All right, good. So we're not gonna do that now. Let's just finish up and finish the drawing. So let me go to my construction layer, and from this middle line here, because remember we had this middle line to separate the drawings by equal distance. From this middle line, I'm going to draw a line, a 45-degree line coming up like that. So in order to get 45 degrees, I need to come here, make sure this is on, and when I get to the 45-degree mark, I would see a green dotted line show up. So I know this is 45 degrees. And then finally, I'm going to run some projection lines, come across from the corners of my object, like so. I'm just going to copy this line, and I'm going to put one here, I'm going to put one here, one is already here, and then I'm going to pull these lines down, like so. So I pull down one, and then I'm going to copy this, just to make it a little faster, put one here, put one here, these projection lines like so. So this is going to help me to draw my object right here, to draw my right side of my object on the right side of the drawing. Okay, so now we need to project some lines across from all the edges. Let me copy this one and place one here, here, and also at the top. Let's see, up here, the top somewhere up there. How high is this? I know this is what, about 20 millimeters. So I'm going to just offset this one 20 millimeters, because the radius of the bigger circle we know is 20. So the top of here is going to be 20. So I offset this line to the 20, and I could just pull this across right there. Okay, because nothing was showing up for me to snap it, and I didn't want to guess using the nearest snap and all of that. So let me just clean this up a little bit. Actually, I don't need to. Let me just clean up this side. So this one, clean this up. Alright, where these lines, so these lines come across and then they turn down at the 45-degree line. Come across, once they hit the 45-degree line, they turn down. So I'm going to be drawing this face, this side of the drawing, which is over here. You should already know what it's going to look like. As I said, it's going to look like a rectangle, right? And because we projected lines, we don't need to measure anything. We just have to follow the projection lines. And because I already know what the object is going to look like, I don't need to think too hard. I know it's a rectangle. I could just verify this is 35 millimeters. Yes. And the height is 20. Yes. So it's correct. So what I need to show now are these cutouts. Now this part comes up 10 millimeters. So there's a line that should be coming across, all the way across, 10 millimeters up, all the way across here. Hidden line, right? This line, right? Notice it comes up here. So that's where this leg ends. So we're gonna have a hidden line running across there. So let me switch to my hidden layer and draw the hidden line going across like so. I'll change the line type scale after. Next thing, from this side, we cannot see this cutout directly, but we can represent it. So it goes in 10, and then it comes down 10, right? So again, I do not need to measure anything. All these projection lines are helping me. If I follow this projection line, I can see these projection lines represent the cutout. So I could see exactly where the cutout is supposed to go. If I follow them come down, the cutout is going to be right here. Okay, so again, line tool, I'm going to bring down this So right there, that's my cutout. The cutout come down and goes across right there. That's how it looks from this side. The next thing I should see is the hidden line that represents the circle, the cutout of the circle um, from this angle. Alright, so from this side, I'm going to see this. It's going to look like a rectangle standing up. How high does it go? It goes as high as the radius of this part, which is 20. How wide is it? 15. Okay, and as you can tell, it is already there. Alright, I can see it right here. Right here. It's going to look like this. If I follow the projection lines, these two lines represent a line running from here and here. Follow them down, we can see they'll come down right here. And then how high do they go? In line with this path. Alright, so we are looking at the object from the right side, and here's how it's going to look. Okay, so we need a line from let's see if I put on the tangent, if I'm going to get a better snap showing up. No. Okay. Nearest. See, I don't want the nearest. So the line is supposed to run from the very top of the circle right here. So what I probably need to do, I could draw a line from the center of the circle, come up there, and where it intersects, pull a line across. But because I know that the radius of the small circle is 10, I'm just going to offset this line here 10 millimeters up. So this line is going to represent the, let me just lengthen it a bit until I get to, alright, so this line here is going to represent the cutout of the circle inside of the object. We can't see it directly through this, but we could represent it. So the top of the circle, we're going to draw a line coming across right there on our hidden layer. So like this. Alright, so that line going across there, that's going to represent the cutout under there. So all we need to do now is just change the line type scale. Let me just match the property of this. Alright, and touch that one, touch this one, and touch that one. So that's what we have. And I think that's all the elements to this drawing. So all we need to do now is just dimension the drawing. So turn off the construction layer, and this is what we're gonna see. This is the front, this is the right side, and this is the top of the drawing. Okay, so all we need to do now is just dimension it. So some rules about dimensions that you want to keep in mind. We can do two types of dimensioning in technical drawing. We can do chain dimension, which is basically this. If I dimension from here to here, 10 millimeters from the object, and then I continue chaining my dimensions onto the object like so. That's 10 and that's 35, right? I can do that. That's chain dimension. But then there's another type of dimension where instead of putting all the dimensions like this, chaining them all together, I can do this. I can put the first two, and then I can put an overall dimension right after it, like so. I'm going to put this one about 18 millimeters instead of 20, just so it doesn't look too far. Alright, so the first one is 10 millimeters away, and then the second one is 18 millimeters away. It really should be 16, but I'm using because I want a little bit more space here. Alright, So if you know a little maths, then you would be able to say, oh, this is 25, this is 10, that's 35, and the whole thing is 70, so that means this side over here is 35 millimeters, right? So that's how we can do the dimension. You can choose any one you want. And here's another rule: in technical drawing, we do not, in this kind of drawing, we do not repeat ourselves, okay, because it makes the drawing messy. So if I have 70 millimeters here, I don't need to put 70 millimeters up here again. Why? Because obviously if it's already here, I don't need it down, I don't need it up here. So you could even remove this one and leave it like this. You show that, and you have the overall above, and then the person would know automatically that this is 35 because I minus this from that. Okay, and then another rule of dimensioning for these type of drawings is that you do not dimension hidden lines. You dimension only the solid lines that you can see. Okay, so something that you always want to keep in mind is that we need to put in all of the dimensions required, but we're not going to repeat ourselves. We're not going to dimension to hidden stuff on any of the views. So we're not going to measure, for example, we're not going to measure from here to here. No, this is a hidden detail. We're not going to measure it. This hidden detail can be seen from here, from the front view. So what we'll do, we will dimension it from the view that we can see it. That's the rule. Alright, other than that, get dimensioning. So let me show, I'm going to just do it one way from here. So I'm going to do the overall and put it 18 away, and then I'm going to do this side from here to here. Let's put that 10, and then I'm going to put an overall measurement 18 away. So if this is 35, then we know for sure that this part is 15. I don't need to say it, I can do maths. Alright, so how far does this go in? Can I show it from another view? No, I can't tell how far does this cutout go in from another view. I can see it here, but I can't dimension it because it is shown in a hidden spot. So I can't do this. Alright, I can't do that and say, oh, it goes in 10. Nope, I have to show it up here. Okay, so I show it right there, like so. And I don't need to measure the remaining 10 because I know this is 20. And if this is 10, then there's another 10 remaining. Simple. Okay, so we have everything we can show from here. Down this side, we are going to be showing this dimension. And no, the truth is we could tell this foot from up here as a hidden line, right? But we didn't actually put any hidden lines. We need to go back and do that. So here we should have hidden lines from here that represents the foot that we are standing on, that side and that side, like so. Just turn off the construction layer and then match the properties. This, turn that into that and that. Good. So these lines here represent these legs, and these legs go all the way back. Like this leg right here, this line goes all the way back to the end of the object. Here, this line, this leg, on the inside, it goes all the way back to the other end. So that means I need to draw this line all the way through to the other end, and this line all the way through, but we already have a line here, so we don't need to really put it. It will just be two lines, same, the same place. So we need to measure this measurement here because we can't show it up here. We don't measure hidden details. So we're going to measure that, and then I'm going to measure, let me do continue. and measure here, and then measure here, and then measure here, and I could also measure right here, or as I like to do, put the overall and let you do a little math. So this is going to be 18 from the object. It's on the wrong layer, so let me just switch it to the correct layer. Dimensions. Alright. And we can show this height right here. But more importantly, we can show the radius of these. So I'm going to use my radius tool, and I'm going to point to this like so. I'm going to point to the bigger one like so. Alright, I think I might move this. How will it look if I put it here? Alright, so like that. Okay. I can also show the height of this piece, this length. And the reason why I want to do that is because I cannot show it from over here, because it's a hidden, it would be hidden. It would be measuring a hidden detail, and we can't do that. So we need to dimension these distances from here. Well, this line come all the way up to here, come across like so. And because my last measurement is from here, then I can't say 10, or from the object I have to say 20. So 10 will bring me here, and then the other 10 will take me out here. So let me say 20, boom. If you notice, we need to put a break because we can't have the dimension lines crossing the object. So we need to go to the annotate, break tool, select the dimension you want to break, this one, and select the object that's going to break it, this line. And there we have the break. Alright. So we have this distance, right? And what's the distance from here all the way up to the top? Well, I'm glad you asked. We're going to put this in right here, bring this out about 18 millimeters. So now we know that this distance is also 10. So yeah, I think that's it for that side. And then over here now, we can dimension this side. We actually have this 35 measurement already over here, because this entire side is the same as this entire side. Alright, we're going to put that, but technically we don't have to, but it's not going to be too messy, so I don't mind. And then I'll do this one 10, and then do an overall like so, 18 millimeters away from the object. Now, how wide is this? We know that this is 15, because if we come up here, this part is right here. Well, the width from here to here, that's right here, from there to there. And if we look over here, we minus 20 from 35, we're going to get that distance, which is 15. But let us show it, because it's not going to make the drawing messy and complicated in showing just that little detail right there. And because we know this is 15 and we know this is 35, then we could know that this distance right here is 20. Okay, so there you have it. This is your finished drawing. When we are showing this, we will have to show it both with the construction lines and one without the construction lines. The reason is that you can show how you developed the drawing, how you created the drawing, right, using the projection lines and so on. So as you know, we need to put a title under the drawing. This drawing is an third angle projection of an isometric block. So that's going to be our title. Text tool, text layer, single line text. I'm going to put an third angle projection. So they specify the height, that's 3, rotation angle is 0. We're going to call it third angle projection, oh lord, of an isometric block or object. All right. Yeah, that's the finished thing. Save your work, and then we'll put these on paper afterwards. Everything is good. So that's it for all of the drawings. Before we did the we plot the path of a locus for a point P on the midpoint of a connecting rod of a crank, and then we did the third angle projection of this isometric object. Now, technically, we are not quite done. We really have to put in the third angle projection symbol. So if you recall, we're supposed to imagine we have, oh Lord, I can't do it right here, but let me just pull it up on the internet. Yeah. So okay, so when we do a third angle projection drawing, we would use this symbol. We would draw this symbol at the base of the drawing, like right here, and that would tell the viewer who is looking at this drawing which projection we're using. Is it fourth angle or is it third angle projection? In this case, we will need to draw this one. Now, I can just show you how do we get these objects, and this will actually help you to understand which one. You could just memorize them, but it helps to understand how do we get these symbols. This is actually how do you say this? Is it a truncated object? Let me try to find something on the internet, on YouTube, to show you. This is just some bonus information. Alright, so here it is. We can see in this video, this is a symbol for the fourth angle projection. It looks like this, with two circles on the right side, and this is the symbol for third angle projection. You have these two circles, and then you have this kind of polygon on the right side. So you see the difference between them. The circles are on the right. For third angle, the circles are on the left. But it's not just a matter of putting one on the other. There's actually a way how we arrived at this. Now, as he's going to show in the video, he is going to actually draw the object in a 3D view. So it's actually an object in 3-dimensional view. Like so. Let me just speed this up. Right. So when it comes to the fourth angle projection, we are looking at the object. This is the front view. When we're looking at the object from the front here, the front goes here, and as we know in fourth angle projection, if we're looking at the object from the left hand side, the left hand side is drawn on the right, which is why we put the circles that we would see from this side, we put it on the other side of the drawing in fourth angle projection. Right? So this symbol is actually us using the same principles of fourth angle and third angle projection in terms of how we position them in the quadrant and all of that. This is exactly that. When we look at the object from the front, we have the front, and then when we look at it from the left side is placed on the right in fourth angle projection. And as we know, in third angle projection, this is going to be a front. Down here is going to be a front. Alright? But then if we look at the object, looking at it from this left side over here, the left side is placed on the left. Because you remember the difference between the first angle and third angle projection.
In first angle projection, everything is reversed. The left side is placed on the right. It's drawn on the right of the front view. But in third angle projection, if you have the front view, the left side is placed on the left. So left on the left, right on the right, etc. But first angle projection, the left is placed on the opposite side. So that is basically what is happening here. I hope that makes a little sense. But we will need to just draw that right there, and put this on paper, and then the drawing will be done. You can always come back to this drawing if you want a little, refresher on how these things work. I know it's a bit long-winded, but it surely gives you an in-depth take on how these things work. Alright, until next time, let me end the video right here. I know it's quite long. Ciao.